Hello students, we have started with module 2, that is processing techniques. So in this we have learnt what is the purpose of processing, what are the different methods of processing the waste. So processing of the solid waste is what the physical treatment by using physical techniques for changing of the composition and the characters of the waste. So this we have discussed in the previous class. What is the purpose of processing? To improve the efficiency, to recover the resources for reuse, to prepare the materials for recovery, and to produce the energy. So we have started with the first processing technique, that is the chemical volume reduction, that is incineration. So what is an incineration? It is a chemical reaction in which the solid waste is burnt, okay, in a furnace that is called as a incinerator. So this is quite a stationary method of refuse disposal, and it is widely adopted in the developed countries where the collected waste, it will have the high calorific value. So after burning, the energy what we are getting, that is more, then it is called as high calorific value. So we have seen how the incineration plant works. So this is how a incinerator plant looks. So the waste is collected in a pit, then with the help of a crane it is sent into the furnace, okay. Then there the solid waste is burnt at high temperature, more than 800 to 1000 degrees centigrade. Then it will the water starts boiling because of the heat which is generated after burning the waste, and that boiler, okay, whatever water is present, that converts into the steam, and that steam will be utilized to run turbines, and the energy is produced, that is electricity, that is used as a energy. And here the gases which are coming out after burning, they will be processed, okay, with the help of air purification equipments like electrostatic precipitator, that is one equipment to control the uh, air pollution. Then finally quite pure gas which are liberated, gases which are liberated, that are sent into the atmosphere, less harmful gases. So this is how you can draw a conventional incinerator plant, okay. So this we have discussed. Now we will start the 3 T's, okay. What are the 3 T's? First T, there are 3 T's in the incineration: the residence time, that is time, and turbulence, and the last one is temperature. So these are the 3 T's of incineration. So we'll discuss one by one. What is the residence time? So the residence time means the length of the time the waste is exposed to the temperature which is required for the destruction of the waste. So means the duration, okay, the length of the time, the for how much duration the waste is exposed, okay, for burning, that is for the temperature that is required to burn the waste completely. So that is called as the residence time, the length of the time the waste is exposed to the temperature which is required for the destruction of the waste. So 100% combustion means the fuel is fully oxidized, and full oxidation of carbon, hydrogen, and other combustible elements has taken place. So the time plays very important role in determining the combustion efficiency. So here the time for which the waste is exposed, that plays a very important role, because if the residence time is less, means the waste is exposed for a shorter time, then what will happen? The waste which is undergoing a burning process, that process will not be completed, right? So the material or the waste which is that will remain unburnt. So that will increase the unburnt losses. So if it is more also, it will cause problem. Okay, so if it remains for a longer time, higher than the required time, then there will be waste of power, right? The power output of the boiler will drop. Okay, because the new fuel will not be able to come in, and it will not get burnt. So that is what the residence time is very important, so it will be optimum. Okay, then next T is turbulence. So turbulence means what? Turbulence ensures a thorough mixing of air, that is oxygen, fuel, and the municipal solid waste as it passes through the combustion chamber. So as the waste passes through the combustion chamber, there has to be a proper or a thorough mixing of all these three components, that is air, fuel, and the municipal solid waste. So that is very important. So why? Because the oxygen is the essential part of the process of combustion. So while burning fuel, it is very essential to break the waste into smaller particles. So because if you break it in smaller particles, the surface area will be increased, and as a result there will be proper burning of the waste. So if the turbulence is not maintained, then what will happen? It will result in again incomplete combustion of carbon, which forms CO instead of CO2. So instead of CO2, if the waste is not burned completely, the formation of carbon monoxide gas will happen. So to avoid that, you have to burn the waste completely, because carbon monoxide is a greenhouse gas. Okay, and also some part of fuel will go out of the chimney without getting oxidized. So this will increase again unburnt losses. So you have to be very thorough with the mixing of the all these three components, that is air, fuel, and municipal solid waste. Then the third T is the temperature, that is the burning mixture, that is air, water, and fuel, that must be raised to a sufficient temperature to destroy all the organic components which are present in the municipal solid waste. So each combustible substance has a minimum ignition temperature that must be attained in a in the presence of oxygen for combustion to be sustained. So it is important to maintain the correct temperature, which ensures that the fuel is quickly burnt, releasing the complete energy. So that is very important. The third T, that is temperature, the burning mixture, that is air, water, and fuel, that must be raised to a sufficient temperature so that it will destroy all the organic compounds completely. So uh, during combustion, what happens? If the temperature is not sufficiently high, the fuel will take some time to ignite. So this will increase the time of combustion. So this will affect the heat output. So the combustion is very important. So the combustion airflow is reduced to minimum level which is needed to provide the oxygen for the support fuel, that is gas or oil or any coal, and the combustible waste without forming high level of CO and unburnt hydrocarbons. That is very important. So this will raise the temperature to a level which is needed for the complete combustion of the solid waste. So this is how the temperature plays a very important role in the incineration plant. Okay, so these are the three T's of incineration. Then we'll see what are the principal components in the design of municipal incinerator. So the first design principle is the scales. So scales are required to maintain the accurate records of the amount of the waste which is being processed. So scales means what amount of waste we are sending into the plant, so that is very important. Then the storage pit, so design of the pit also is very important. So it depends upon the furnace capacity. Okay, depending upon the furnace capacity, then storage requirement and the collection schedule, and also the truck discharge method, which type of method is being used to discharge the waste. So all these factors taking into account, you have to design a storage pit. So the design of storage pit depends upon the furnace capacity, storage requirements, collection schedules, and the truck discharge method. So this is all about the storage pit. Then the third principal component is the cranes. Okay, the crane which will pick the waste from the storage pit and it drops the waste into the furnace. So the cranes which are used to transfer the waste from storage pit to the charging hoppers to mix and redistribute the waste in the storage pit. So that is what the role of the cranes. Then the charging hoppers, so that is constructed of metals or concrete, and they are used to introduce the waste to the furnace grates. Then the next principal component is the furnace grates. Okay, so they are used to move the waste through the furnace. Traveling, reciprocating, rocker area and barrel grates, they have been used successfully. So these are the different types of the furnace grates on which the solid waste is burnt. Then combustion chamber, so this depends on the capacity of the unit and the fuel characteristics. Then the next is the heat recovery system. So the type of system, again it will vary. So typically two boiler sections are used, convection and economize. So these are the combustion chamber or heat recovery system requirements. Then auxiliary heat, so auxiliary heat means what? This need depends on the moisture content of the solid waste as delivered. So if the moisture content in the waste is more, you need more auxiliary heat to first remove the moisture content from the waste and then start the burning process. So this depends upon the need of the auxiliary heat. It depends upon the moisture content of the waste as delivered. Then the air pollution control facilities, so these are used to control the particulate and gaseous emission which is coming out of the burning of the solid waste. Then the auxiliary facilities and equipments includes normally the residue handling facilities, that is the ash which is coming out after burning. Okay, that we have to handle it, so that facility comes under auxiliary facility. Then air supply, exhaust fans, incinerator stacks and control buildings, etc., they are all come under auxiliary facilities. So these are all the principal components in the design of the municipal incinerators.